Warramie, welcome to Hub Chats, a podcast created by the Macquarie University Teachers Learning Hub here at Macquarie University in Sydney. I'm Dr. Jodie Torrington, and our Hub Chats podcast aims to make the latest research accessible and practical for teachers by having a chat about it, both with academic experts and educators. Before we start, I'd like to acknowledge the traditional custodians of Macquarie University land, the Wadawurrung people of the Darug Nation, whose culture and customs have nurtured and continue to nurture this land. We pay our respects to elders past and present, and we extend a warm welcome to any Aboriginal and Torres Strait Islander listeners. Today we're talking about mathematics education, and I'm so honoured to be joined by renowned maths teacher and all-round legend, Eddie Wu.
Morning, Jodie.
Welcome.
Thank you so much for having me.
So Eddie is an award-winning maths teacher, leader of teacher growth for the New South Wales Department of Education, classroom teacher at Cherrybrook Technology High School, YouTuber known to students worldwide as Mr. WooTube, and also a professor of practice at the University of Sydney. In 2012, he started filming his classroom lessons for a student too ill to attend school. He uploaded them to YouTube under the name WooTube, and what began as a simple act of care has grown into a global phenomenon with over 2 million subscribers and 180 million views worldwide. In 2018, Eddie was named Australia's local hero at the Australian of the Year Awards and recognised as one of the top 10 teachers in the world by the Global Teacher Prize. He's also a published author, a TED speaker, leader of the New South Wales Teacher Growth Team, TV host of ABC's Teenage Boss, Channel 10's Ultimate Classroom, and a fellow of the Royal Society of New South Wales. So, can we just do a big meaty one to start? Why did you become a teacher? What interested you in going down that path?
Jodie, the love of teaching for me started fairly early on. And I feel very thankful that whilst many of my friends were trying to work out what should we do with our lives, and I went to one of those kinds of schools where many of my peers just got astronomically high UAIs. We didn't have ATARs back then for any listeners who are a little bit younger. And they were kind of working out, all right, do I do medicine? Do I do law? Do I do engineering? The world was their oyster, but they didn't know necessarily what was going to really resonate with them and what kinds of professions and careers would be really rewarding. I think I was probably only about 15 or 16 years old when I had the first experience of assisting another younger student to learn something. It was actually in the context of being part of my school's cadet unit. I think we were pitching a tent or polishing shoes or starting a fire to keep them warm around the campsite. And that experience of helping someone else learn a new skill, develop new knowledge, and for them to change their self-concept, for me, that was an amazing experience. I initially thought, everyone loves this. And then I realized it was something quite peculiar to me. So that is what set me on the path toward teaching. And mathematics came into view when I realized, upon arriving at university actually, that there was this critical shortage of mathematics teachers across Australia, indeed a lot of the Western world. And because the thing I've loved about teaching has always been making a difference in the students, it's less so about the subject discipline. So changing to mathematics wasn't that difficult a decision for me, and I've never looked back.
Wow, fantastic. And I guess another big one, what drives you now? Like, in terms of, we know you're such a busy person. Your day starts early. You're, in charge of this teacher's growth team. You're in the classroom as well, whether that's at school or university. You've got this amazing YouTube channel that you have to keep active as well. Like, that's a lot to juggle. So that must be an amazing passion and, enthusiasm. But yeah, from you, what drives you?
I do feel grateful that all of the things you just listed are things that I'm extremely passionate about and that I have this great energy and desire to make a difference in. And I know every kind of work has the aspects of it that are a little bit drab, and I'd prefer not to do this paperwork or this admin and that kind of thing. It must be done. But I feel as though the proportion of things that I do where I can see the impact and the difference that this makes, either for a small scale, just the 30 students in front of me, or a large scale, the New South Wales Department of Education, we have more than 2,200 public schools spread across the state. That's the largest education system in the Southern Hemisphere. So knowing that, I get to make an impact very immediately on the students in front of me, but also in the longer term and at a larger scale, as well as all the bits in between. For me, seeing that impact, I think I'm just very impatient, and I love knowing that I'm making a difference, and all the different ways I get to do my work give me illustrations of that every day.
And what have you been up to recently? Can you tell us, or super secret things?
There's always a few things I'm keeping in my back pocket. So, and I feel, again, very thankful that I get the opportunity to work on longer term things that sometimes it's like, all right, not ready to share about that yet, but I am always working on some things that are at the forefront of my mind. So two of the things that jump to mind are, firstly, really trying to think about what middle leadership looks like in schools. I began my journey as a middle leader, formally anyway, when I was about 6 years into my teaching journey. And at that point, I definitely didn't fully comprehend the complexity and the tension of a role like that, where you are at the proverbial chalk face. You are working with a small team and closely supporting them, but also you have these larger leadership strategic priorities. You've got the reform of curriculum. You've got all of this different research and evidence that's guiding and nudging your practice. And somehow you have to make sense of all of that, synthesize it into one coherent direction, and then hopefully lead a team effectively in order to do that in a way that helps them and is supportive. That middle leader role is something which over the last 11, 12 years, I've come to understand better and see is so crucial in the success of our schools and the learning of our students. So that's the first thing that's at the forefront of my mind. The other thing that I'm thinking a lot about right now is something that's been a little chestnut that's been sort of bubbling away. Sorry, I'm changing metaphors in my mind for many years, but it's about the role of technology in learning. And of course today, and I know this is something that you know really well, Jody, more than most, it's that artificial intelligence is in some ways a technology just like every other technology that we've seen come into education, that we need to work out how to thoughtfully and critically use it to aid our students and our teachers. But it's also fundamentally different in some ways that demand new understanding, new thinking, and really strategic care in how we help our schools adopt a helpful and adaptive way of using that to aid learning. So that's also at the front of my mind. I've got some fantastic colleagues who are supporting me with that because I know some parts of the puzzle, but there are other things that you really need broader expertise and knowledge on that. So I'm very grateful to be able to do those things.
And is that specifically in terms of mathematics education or more broad, or you can't say?
Yeah, no, it's a bit of both. I obviously, as someone who's a mathematics subject matter expert, that's often where I begin. But I do think that I actually remember quite recently having a conversation with the English teachers at my school and seeing the level of kind of existential questioning around, if a large language model can help a student write an essay that is much better than the one that they might have written without that kind of support, then what is it that we really value in student learning and achievement? And it's the same kind of question, not identical, but it's a very similar kind of line of reasoning that mathematics teachers went through sort of 20, 30 years ago when scientific calculators becoming very common. Sort of, okay, if calculation and computation are things we can now happily offload to a technology, do we want that? Is there some space or context in which those skills are still important to developmentally? And if so, for how long? When do we stop caring whether a child can multiply, 3-digit numbers one by the other and just get the technology to do that so that we can ask more interesting questions?
That's the thing, isn't it?
So there's
but
a whole...
it's hard, isn't it? Because a
exactly
calculator works on the input you provided and that's it. It doesn't generate its own sort of output. Do you know what I mean? It works with what you provided, and that's what's different, about
it's
AI,
a new
large
horizon that we're
models.
needing to cross at the moment. So that's why it's such interesting work to go through.
Yes, and very needed. Yeah, for sure. Okay, so I'm going to ask you some questions about maths mindset. So I'm working from some questions that we've asked people on our LinkedIn and others that we thought we'd like to ask you. So, do you have a philosophy for helping students who believe they're just not maths people?
I love this question because the first thing to say is that is most of the students who I encounter, and certainly a lot of the adults when I meet them at, a wedding or, you're waiting at the airport or, you're sitting beside someone in the plane. It's like, what do you do? And once they find out I'm a mathematics teacher, there's all of this trauma that they're ready to unburden on me. They're like, aha, it's your fault. And I have to sort of vicariously stand there as the emblem of mathematics education they've received, good or ill.
You're so positive though.
Well, you have to, sometimes you have to laugh, otherwise you cry.
Yes.
So coming back to the question, I definitely have a whole kind of toolbox is what I would say for how to work on and address that mindset. I say a whole toolbox because I mentioned a class of 30 students before. In a group that large, you're going to have a lot of different backgrounds, experiences, and the diversity of that audience, of that community, demands a multiplicity of different approaches. I've found it's very seldom that just one thing will just work for the entire class, let alone, average high school teacher's got 150 students that they care for. So you really do have to have a broad and deep toolbox. I think that there's a lot of go-tos in terms of I want a student to be able to connect the mathematics that I'm teaching to the things that they care about, which of course means that before I'm going to go in there and provide any input, actually as a teacher, as an educator, there's a whole lot of listening and learning that I have to do to be able to wrap my head around what is it that makes this student tick, what are they passionate and interested in, and how can I sort of adapt to them. I also think though that actually, even though that's very powerful, most young people are not searching for this is the job that I'm going to be doing in 3 or 4 or 5 years, and therefore this is the kind of thing that I want to practically equip. Because, if you've got a 12 or 13-year-old student, they're not really thinking about their future career prospects. Even at age 17 or 18, they still may have a lot of uncertainty. I think often when students are expressing to me that mindset you mentioned before in the question, that maths is just not for me, that's really a statement about their experience of mathematics and that they've found it disengaging for perhaps many years at that point. So
I want them to sit in that with students, because mindset can be such a I don't know, it can affect whether they're even willing to give something a try, or be vulnerable and take risks and, trust you, I guess, to perhaps then change their mindset. So, do you talk about their mindset of maths or not really, or kind of comes through organically with
Again, a little bit
activities?
Like I sort of referenced before, I think it depends on the student. I think there are some for whom being specific and explicit in talking about, I care about your attitudes, beliefs, and convictions that you bring to this classroom. And some of those are things which I want to address and I want to tackle, and I don't want to pretend that they're not there. Yeah. So I do think that's important, but I also think that sometimes you need to, as it were, take a bit more of a stealth approach. Say, for instance, I think about programs around student well-being and, say, for example, anti-bullying programs and talks that happen in schools. I know this sounds like it's a bit of a left turn, but it's not as unrelated as it may seem. Often, being very direct and explicit about that is what we need. And we want to have a clear standard of behavior and expectations about what kinds of ways we should interact with each other. But I've had many students say to me, and I've even heard my own children say, these messages are important, but the people who need to hear it most, they're not going to be convinced and persuaded by you giving this very, explicit message of saying this is the wrong thing to do. They already know that. And so often, saying, okay, there's some unhelpful mindsets here in this classroom. Telling people, Jody, I want you to feel better about maths. Can you try a bit harder? It's like, well, that's not gonna change things.
I guess it's on the other end, isn't it?
That's right.
Reflecting back and
how
are you feeling?
100%. And even little things like, what are the interactions like in the classroom? How do we address mistakes and errors? All those little micro interactions, I think, are what build up the culture and cultivate the mindsets in a classroom.
Good point. So here's an interesting question for you. What do you think studying maths does for a person's mind or character that goes beyond just numerical literacy? That's a meaty one.
It is meaty. I think the best way that I can answer first is by not providing an answer that I have, but one that a dear friend of mine, Francis Su, who's a mathematician in the US. He's at Harvey Mudd College, a fantastic, knowledgeable, brilliant educator. And he wrote a book which I highly recommend to any of the people listening. It's called Mathematics for Human Flourishing, which even the title itself should, I hope, pique some curiosity. And this idea that courage, justice, equity, curiosity, these are things which are very different from just straight academic content and outcomes. And yet, I think Francis mounts an extremely compelling case, and I would agree with him, that these are actually attitudes and values that are wonderfully engendered by mathematics. You know, when we care about equity, for example, how do we even understand that a situation is inequitable? And the answer is, well, we need to understand the data carefully. We need to be able to sift out when we see patterns in society. We need to sift out correlation from causation. We need to be able to understand patterns of where there are real areas of economic disadvantage and what is causing those. Mathematical thinking is at the forefront of how we can understand those problems, comprehend them, and then come up with solutions.
That's very good, because my mind just went to balancing equations. You're
And,
incredible. I
That's
like
a
what you're
critical part
saying.
of that, right? But yes, I just think that there's a broad range of approaches to problem solving and thinking mathematically that serve us socially and as human beings.
Well, in your experience, is there a danger zone, like age or stage perhaps, where you've seen students are most at risk of just deciding maths isn't not for them, or they switch off or anything like
I would say that there are several junction points that matter. And I also want to acknowledge that even though I describe these as junction points, I really want to say to everyone listening, it's never too late. Like, that's an important thing. Before I talk about, at this point, people really struggle and it's really hard to get back on. It's like, it's challenging, but it's never impossible. And I think a lot of us write ourselves off far too early. I see this in young people. I see it in slightly older people too, who just closed that door and decided, too hard basket, never coming back. And so even though I think that there are some particularly important crossroads, which I'll name in a second, I don't want it to ever be a fatalistic thing that's like, you didn't get this, we're out, right?
Yep.
So I would think about, firstly, at a really young age, even prior to entering formal schooling, it's about that attitude towards loving numbers and wanting to foster an appreciation for the patterns around us. So it's usually a pretty common thing. It sort of comes out of the box that children love counting things and knowing how many of the thing that they have. You seldom have to tell a child, like, I'm going to test you on this. It's like, oh no, I just love being able to say, I know how many there are, and the ability to quantify is just a normal part of the development of a small child, right? And being able to say that's wonderful, and that can be fun and enjoyable. That happens before school begins, and I think that's an important beginning. Then when we move into primary school, as there's this transition from counting into additive and then multiplicative thinking, and that tends to sort of, that transition happens around year 4, year 5, year 6. There's this heartbreaking moment where sometimes I will ask a student in year 7, can you calculate for me something like 108 divided by 3? And there's a lot of different ways that you can answer that question, but I know, because I've seen it happen, that there will be a small subset of students and they will start drawing tally marks on their page until they have 108 tally marks. And then they will start circling groups of 3 because they have this is the technical term, they have a quotient mindset to division, and they don't know that there are other more flexible ways to think about that. And that's all part of multiplicative and proportional reasoning. So that junction, that sort of leap tends to happen in late primary school. And it's often the difference between students who successfully navigate fractions, decimals, and percentages in years 7 and 8, and those students who really struggle and they really don't have that foundation. And then as a last thing, I would probably say, as students move into this very abstract and symbolic representation of numbers, when we move into algebra, this idea that, I mean, it sounds quite scary and intimidating, and it often isn't taught in a clear way, but it really is just working with numbers when we don't know what the numbers are, which is something which is phenomenally powerful. And we do it all the time when we think, okay, well, I need to get to somewhere at a certain time, and I don't know how much time I need to allow, but I'm going to plan around my journey anyway. That's algebraic thinking at play. And so if we can see, oh, this is something I do all the time, and it's something that I want to value, that again is something that happens around early to mid-high school, which sets the foundation. So I could name even more junction points if it were important, but those are the critical ones that seem like places where a student may not grab that, and then they find it very difficult to recover after that.
Another quite interesting meaty one from our LinkedIn. What do you think about the health of the larger culture around maths in Australia? And what would you suggest to improve it?
This is so tricky to answer. It's a really clever question. It's tricky to answer for me because I see so little homogeneity across the mathematics culture of education in Australia. I'm really thankful that I get to visit lots of schools around New South Wales, in regional areas, and even around Australia. And I find it extremely hard to generalize. You have schools in which the only form of mathematics teaching really is direct instruction. And direct instruction is extremely useful, especially at, the early knowledge acquisition phase of learning. But if it's the only tool in your toolbox, it's extremely frustrating, frankly, for students to only ever be told, here's a rigid set of processes and algorithms that once you master them, you're good at mathematics. That's not true. The ability to be able to inquire, to discover, to problem solve in a novel and unfamiliar environment, that's really important in mathematics learning, and it's very hard to develop that skill if all you get is direct instruction. And if I were to then go all the way to the other end of things, there are settings in which I see students who are being given a very free-form, discovery, inquiry-focused approach to learning, where the teacher views themselves exclusively as a facilitator. Now, again, there's enormous power in a teacher getting off of the stage, getting beside a student, and, Socratically questioning and developing and cultivating their own knowledge. I do that all the time. But if that's the only approach that I use, then I'm really doing my students a disservice and giving them an extremely inefficient path through developing the knowledge and skills that they want. And so I find this question rich and delightful, but also really hard to answer. I guess maybe in some ways what I've just alluded to is the fact that there is this breadth of knowledge and strategies and educational research that I think all Australian educators would benefit from having a broader and more nuanced understanding of. And I think that's challenging because every teacher is time poor, and developing a deep understanding of the evidence base is hard and time consuming. But I think that the further we can go towards that, the better we'll be able to educate our students.
Thanks. Another LinkedIn one. How do you teach students who do not enjoy mathematics?
I think that enjoying mathematics is something which, again, it takes a wide variety of different strategies. So
Yes.
I use lots of games in the way that I teach, but often I'm going to reference the work of Dan Mayer in this space, who he works a lot in the technology space of mathematics education in the US. And his phrase is, you've got to help students feel the headache before you give them the aspirin. Now, I'm asthmatic, so I don't use aspirin. Nonetheless, I understand the metaphor that actually, enjoying a subject often comes from feeling, I want to know the solution to this. And every time you read a novel or watch a film, a great novel or film will do a great job at putting in us a seed of curiosity and a tension that makes us say, how is this going to be resolved? How will we solve this problem? How will the hero overcome the villain and, reach a happy ending? And so I think that for those students who don't enjoy maths, it's about helping them realize, hey, there's something in here that you'll want to resolve, and let me help you experience that problem and show you there's a way to actually solve this. It's really powerful.
Thanks. Okay. Another LinkedIn one. What are your thoughts on the emphasis we now have to give explicit teaching? And how do you think it works best in secondary maths lessons?
I'm a teacher who has been extremely explicit in my approach for my entire career. And part of why I do that is because, well, firstly, I'm not someone who is naturally gifted at mathematics. And so the only way that I can teach it in a successful way is to have done this assiduous planning to ensure that this is clear in my mind, why every activity is there, why every line of working goes from one to the next. In that way, I somewhat accidentally stumbled on the power of being extremely deliberate and structured in how I plan out a sequence of learning. And then I've seen that at work and its efficacy in the classroom. I think that the emphasis on explicit teaching is extremely valuable so long as we acknowledge that explicit teaching itself is a very broad umbrella. It includes not just, that detailed planning process that I mentioned before, but it's about how you check for listening, check for understanding, and then check for fluency. These are all different things. How are we using dynamic questioning approaches in the classroom so that we are using enabling prompts and extending prompts? And I know ahead of time what kinds of misconceptions or non-conceptions, as I like to call them, a student who's just going through a process, they don't know why they're doing it, but they get the right answer. All of that comes from explicitly thinking about the process and, whether I write my learning intentions and success criteria on the whiteboard before I start my lesson or whether I reveal that part the way through because I don't want to spoil it at the beginning, all these things are parts of the nuances of how explicit teaching can be implemented. So I think the emphasis is helpful, but I implore people to understand the breadth of what's included in explicit teaching.
And understand from what you've just said, the benefit to you as a teacher too, to be thinking through and preempting the, problem spots you might come to and where people might need help and being aware of that. Yeah. And like you've said before too, a toolbox where you do games as well and perhaps inquiry questions at different times when it's appropriate. Hey?
And I'd say as well, Jodie, I mentioned that I somewhat by accident stumbled on the value of explicit structure and planning because I don't come from a place where I just naturally understand the mathematics without any great effort. But I would say that anyone who is extremely natural and gifted at whatever their subject area is almost has even more reason to be explicit and careful in their planning because they are definitely going to teach a large proportion of students who are not like them and who aren't going to naturally gravitate towards or have this epiphany of like, oh, it all clicks and it all makes sense. You're probably going to teach a lot of students like me who need that carefully crafted and designed approach to learning with lots of different approaches built within it so that they can learn because not everyone's going to be like a gifted teacher.
And then that's the art and science of teaching, isn't it? Where you then realize once the novice learners have that firm foundation established, then applying that knowledge, like maybe you'll pull back or maybe you do more of an inquiry approach or like give them a little bit of, a different problem solving experience or something like that.
It's why knowing students and how they learn is standard one of our professional standards for teachers. It's because it has to be. All effective education and teaching is a dynamic and responsive process.
Yeah, that's for sure. Okay, another LinkedIn one. What are your tips for students studying for HSC maths exams, particularly extension level?
I'll give a couple of different examples here of things that I advise my students to do. The first one is that, and I think this is common for many students who are, naturally quite strong in a subject. That's why they took the extensions, but they often neglect the foundations. And these are the things that trip people up. If I had $1 for every student who came to me long after the HSC was finished and said, oh, you know what? I actually didn't get my Band 6 or my E4 because it wasn't because of those really tough questions. It's because of some really simple, working memory overloads or fluency mistakes that I made earlier in the exam on those simple 1 or 2 mark questions. So I guess one of the things that I would say there is don't ignore your foundations. But the second thing is just the power of explaining. I think that explaining and being able to communicate to another person is not just a mechanism for medium for communicating thoughts to someone else. It's a mechanism for constructing your own thought. And sometimes your own lack of understanding or misconception only becomes apparent when you are trying to articulate to another human being why you did what you did when you were trying to solve a problem. So I think one of the reasons why I'm any good at maths is because I've been talking about it and explaining it for many years now, for hundreds and thousands of hours. And that's revealed to me the areas where I needed to dig a little deeper in my own understanding and reach a better grasp of what I'm trying to understand. So I hope that's helpful to the students out there.
For sure. Okay, can we talk a little bit about your videos?
Sure.
Okay, so what was the reaction when you first started recording your videos and putting them on YouTube?
There was a few different responses. I think about the teachers first who were hearing that I was doing this and the leaders at my school. And I think back then, I started doing this many years ago. I think they probably thought, YouTube, isn't that thing with cat videos on it? That's like, I would doubt that there's any much educational value here. So I think it kind of flew under the radar for some amount of time. But with my students, I know that they immediately became curious and they saw it. The students, for example, the ones who found out about it this first were the students in my classes for whom I was not mainly thinking of them. I was thinking of, as you mentioned in your introduction, this student who I was going to be sending these videos to. But they quickly worked out like, hey, is that somewhere that I can get to it as well? And I initially would think, you're here in the classroom, you're in the lesson. Why do you want to look at this afterwards? And they would say, well, look, sometimes I'm confused about something. It feels clear on the day in the lesson. Then I go and I'm doing my homework and I think, wait a second. What did Mr. Wu say about this thing? And I missed that in my notes.
Yeah.
Or it might have been months down the line. They're preparing for their exam and they realize, oh yes, this was the topic that confused me. I want to go back and not just look at the textbook, but I want to hear the explanation and see the way I talked it through. Yeah. And so I think what I came to realize was it was students seeing those materials that I put online as a way for them to take a bit of control and have a bit of agency themselves over learning. And that was really exciting to me because it was not something I intended or really designed, but the students themselves saw it as an opportunity. So I was very grateful that they used it.
And they would have the agency to press pause, re-watch, go back, watch it as many times as they want, with that familiarity of you there on the screen. So how powerful. Did you notice a change during the COVID years, or did you have a surge in popularity then, or what happened there?
There were a few spikes there when we moved into remote learning, of course. But an interesting thing happened there because obviously in 2020, when all of us suddenly had to, Apollo 13 our way into working out a learning from home structure in our schools, one of the things that I know, you've had some experience with this too, and I saw this in my school and in many schools, was that even though people found my videos useful, teaching and learning is not just about the transmission and receiving of knowledge. It's about a relationship between a teacher and a learner. And many students craved not just hearing some random guy from another school. They wanted their own teacher who knew them and could explain to them, and they had that dynamic established between them. So even though, yes, we definitely did see a surge in viewership and things like that, it reaffirmed the importance of the relational dynamic between a teacher and student, because even though those videos existed, students also wanted to see and hear from their own teachers.
Although, interestingly enough, there's research out there that when you become familiar with someone's videos who you watch often, like yourself and your YouTube channel, you feel that you have that rapport and connection with them, even though you wouldn't know the people watching them. So that's why you probably get heaps of fans coming up to you.
It does happen every now and then.
Yeah.
It's very sweet. But it is, to your point,
Yeah.
we've learned a lot about parasocial relationships over the years, and it does become sort of like a home away from home. It's like, oh, okay, especially because I have so many years of videos and I've covered everything.
Yeah.
People can search for whatever it is they're looking for, and years 7 to 12, they will probably find it. So I think that has been a powerful aspect for learners.
Yeah, fantastic. So just a quick one about teaching with a camera in front of you. Did that change your approach or affect how you teach?
I think it did feel a little weird to begin with, but I have done this so many thousands of times now that it has long become something that's part of the furniture. That being said, I don't know if this was entirely the intent of your question, but one of the things which I think is amazing is there are lots of things that we do that we don't know that we do. And even if there's someone in the classroom who's observing you, I've observed many teachers, and I'll say to them, "You're doing something like this," and they're like, "No, I don't." Right? It's like, that doesn't sound. Maybe that's what you interpret, right? Or there's this kind of objectivity that comes from the camera lens, which just can't be replaced. So I've learned a lot of things about my own teaching. Some of which I realize is positive. Some of which I think, to my horror, like, why do I do that? I really should change, that approach to how I explain something, how fast I talk, how much wait time or how little wait time I have when I pose a question to students. All these kinds of things have absolutely changed the way that I teach. So I would commend that to anyone, putting that magnifying glass on their own practice.
So true. All right. So getting into a bit of the technology talk, in terms of, I guess, maybe broadly to start, the role of technology in mathematics education. What's your take on that in terms of to support, enhance, or do you think the opposite?
Technology has always had an interesting relationship with mathematics because we pretty quickly reach the limits of our own mental hardware when we are thinking about the problems we want to solve and the kind of computational complexity required to be able to solve those problems. So as an example, I think about something like, say, if you are trying to understand a situation that is rhythmic and cyclical. So if you think about, say, for instance, the rise and fall of a tide, that's something which, as the moon orbits the earth and it moves our oceans up and down, that creates this sinusoidal wave that is part of the heart of understanding trigonometric functions. Now, trigonometric functions are not easy to calculate by hand. And when we went from the junction of being able to go from slide rules to log tables to being able to say, I can just press a few buttons and I can just get an answer immediately, that drastically changed the kinds of thinking and problems I could hand to a 17-year-old student. I could say, tell me what time the tide will be this so that my boat can go out to sea. I don't need a complicated machine to do that. I can ask you, oh learner, with the aid of technology to work out actually this quite sophisticated question. So when I think, therefore, about what graphing software is enabling us to do or what large language models are enabling us to do, I'm really excited about the possibilities of all these different things. It opens up new opportunities for thinking, new problems we can solve. It does, though, absolutely create risks whenever we use technology to outsource some of our thinking. The danger of cognitive offloading and the passenger effect is always there. And so we have to be critical and judicious users of technology, whatever they happen to be, so that it aids and amplifies our learning rather than actually, reduces the amount of thinking and learning that we're doing.
Great. Do you use AI? I know you yes.
I use it all the time.
Yes.
And I would say, to be honest, on the grand scale of things, I'd probably classify myself as still a novice in what AI can do, and, making sure that, I use it safely and in ethical ways. And I'm also mindful of the biases that exist within it. I think it's really dangerous whenever anyone designs a technology and optimizes for engagement, because that's the business model. We've seen lots of ways that has been extremely problematic. And AI is no different in that way. And so because chatbots have been passing the Turing test for some time now, and it can feel like you are interacting with a person who comprehends and understands, it's really easy to let that guard down.
That's
so
right.
I think, explicitly understanding and teaching that is a really important skill for our teachers and students.
Are you teaching students how to use AI for their mathematics?
I think at the moment we are at this interesting point where, syllabus design and curriculum reform are slow ships to turn. And so the way that our syllabus is designed at the moment, it isn't constructed to intentionally provide opportunities for where we can thoughtfully use AI. And so we're kind of at the moment sort of bolting it on and improvising ways of using it. As an example, one of my favorite things to do is that even though large language models have moved a long way since the beginning, we still find that it's not actually mathematically reasoning. And so if you pose a question to AI, it'll sometimes delightfully, confidently give you a wrong answer.
It will always give you a confident
And, it'll be very polite when you tell it that it's wrong. And then sometimes it'll hand you back exactly the same wrong answer.
Yeah.
And so being able to say to a student, hey, I want you to be very careful in how you use that. That is something that I know I explicitly address, because it's just a tool that's so enticing and easy to access. So whenever that's the case, we have a responsibility as teachers to be on the front foot and take the initiative to help our students use that well.
So it'd be quite interesting, to be teaching, even when you're talking year 12 students revising for exams, to use it to explain to the AI, to teach the AI how to do their various things they're actually revising, as an approach to help their thinking and understanding.
Definitely.
Yeah. All right. So just to wrap up, I guess, big picture question again about dreams and hopes and all of that. Where do you hope mathematics education is heading? Like, if there's anything you'd want to implement or encourage, if you had the magic wand, and
If I had a single, here's my wish to the genie in the bottle, I think it would be around something that is actually very old in many ways in the scheme of things, and it's about having every teacher and every student have a clear sense of what are the strands of proficiency, not the content areas, but the actual characteristics and qualities that make someone a mathematician. I would love for teachers and students to have a clear idea of what that is, and to prize that and want it and work toward it. So, in a New South Wales context, we call that working mathematically. We talk about understanding and fluency, reasoning, problem solving, and communicating. And these things, they're kind of like, here's the metaphor that I like to think about. If you want to cook a meal, there are these sort of separate domains of mastering French cuisine and Italian cuisine and Japanese and Indian, and they seem quite discrete. But no matter what type of food you are cooking and preparing, you are still going to need to know how to use a knife carefully, how to control heat in a pan, how to be able to taste and balance flavors as you're in the process of cooking, and then how to plate up beautifully. Those competencies are the same no matter what you're cooking. And the proficiency strands of working mathematically are the same no matter whether you're exploring number and algebra, measurement geometry, probability and statistics, or any other mathematical domain. And those are the things that I think are most important and stand out. And I want students and teachers to say, this is why we study maths in schools. Even though it breaks my heart a little bit, I know that my students are never going to use the cosine rule in the way that I teach it to them in years 10 and 11. I still teach it though, even though no student is going to be like, oh gosh, here I am trying to plan out my garden. Thank goodness Mr. Wu taught me the cosine rule. That's not what I care about. I care about the cosine rule because it gives me a theater, a space, a medium in which for me to help my students learn understanding and fluency, reasoning, problem solving, and communicating. These are the skills that I care about. In much the same way that, you know, a student may never have to quote Shakespeare in their life after they leave school, but the understanding of character, plot, narrative, tension, language, these are things that we should care about forever for the rest of our lives. So that I think would be the one thing. I see pockets of it around the schools that I work with, but I'm yet to find a time where that's something which is universal and consistent. So that's one of the things which I'm really working towards.
The restaurant of Eddie.
Something like that.
Love it. That's fantastic. Well, thank you so much, Professor Eddie Wu, for coming on and talking about mathematics and education. I'm sure your advice is going to be greatly appreciated by our listeners. So we hope you enjoyed our Hub Chats. I'm Dr. Jodie Torrington, and until next time, thanks for listening.